Do you have any question from the last lesson? No? Okay, and let me share my screen. Here. Screen 1. Okay, can you see my slides and also hear my Visual Studio? No, my Visual Studio.
Yes, we can see that.
Okay, very good. So as you remember, in the last lesson, in the previous lesson, I didn't have I couldn't work with my PC, and I had to use my laptop. So I wanted to give you some examples on how to create a header file and a CPP file, and how can you do forward declarations. So today I'm going to give you one example on that. This is the project that we have created in the first lesson. Now I'm going to create one header file here from this menu, header file. Usually your header files are a place that you can define, that you can put the declaration of your class there. But sometimes, but it's not, it's a good habit to be like this, but sometimes it can be like it can be used for the other tasks. So since you are not familiar with classes, now I'm going to give you an example in which we implement forward declaration for our functions. But it's not really common to be like this. This example is just a way to show you what a header file is doing, and what's the purpose of having a CPP file, and what is forward declaration. So I'm creating here a file named just not declaration, maybe my func add, and one here a CPP file, and I name it with the same my func. That's CPP add. So in my func, as you can see here, Visual Studio by its default, it will write pragma lines for us here. I will explain it later, probably in the next lesson, but for the moment, just know that in our H file, we have a macro, which is defined here, and it's pragma ones, and we'll discuss about it later. But we should not write such a thing in our CPP file. As you can see, it's just an empty CPP file. Here, I will write just one example int get ID, and just like this. So it's just the declaration of our function, and now I'm going to define it in my func.cpp. First of all, I should include this file here, the header file. What does it mean? It means that copy this data from here to here. So all the things that we have in our H file, when compiler is converting that code to the machine language, it will copy all these things here, but you will not do that. And here I'm going to define this function. I'm just returning one value, 12. So it's just an example that is showing to you that what's the forward declaration and what's the usage of header file and CPP file. Okay, now I want to use this function in other locations, in other files. How can we use it here in our .cpp file? I need to again include that header file, my func, and here I can just write cd out and get ID Okay, if I just run this code, you will see that we have it here 12. So this is not really it's not a really good example. I mean, it's not a proper way of using the language, but it will show you, it's showing to you that what's the forward declaration and what's the usage of header, and I mean how header files and CPP file works together. So if you want to define a class or other things, usually it's like defining a class. You will have a header file and a CPP file. Inside the header file, you will put the declarations, and in CPP file, you will define them. And since, as you can see here, I'm using a public notation for my class. It's just my naming convention. It's just a naming convention that I'm following. And in other languages, it might not be like this. Or in other companies, it will not be like this. Why it's public? Because it's written in the public scope of my program. So as you can see here, main doesn't need to write anything. It doesn't have any namespace. I can write here or here a namespace, and then if I like this one, and if I write that in the namespace, when I'm going to call it, let me do it here. Namespace VUB, and write this one here. So first of all, to define this one here, I have to write VUB for that. And as you can see now, I can see get ID. And here, if I want to call it, you can see that I do not have, it's not defined, it's undefined for us. And I have to write VUB here. And it's a better way of writing our code. I know that the get ID comes from. I know where it is. So it's important to have such a thing. If it was a class, then we have the name of the class here. So if I define multiple functions here in any order, and if I define them again here in any order, no matter what the order, doesn't matter here, because we put the declarations in another place and we put the definition in another place, and we are including all the declarations here, also here. So there is no problem with the order anymore because we are using forward declaration. But when we have classes, we will see more examples. And let me see. Is it clear? Okay. So let's start our third lesson. Oh, I think I can switch it from somewhere. Yeah. No, I know from display settings, swap presenter. Okay. Oh no. Okay. Oh, I need to switch up. Okay, this is the third lesson. Last time we talked about expressions, if-else statement, the conditional operator, the switch statement, functions, recursive functions, loops, function parameters, and arguments. In this lesson, we are going to discuss, first I'm giving to you the solutions for the exercises that I gave to you. I hope you have done it at home. Function parameters and arguments, then we discuss about, we have talked about function parameters and arguments in the last lesson, but there was still one way that we haven't discussed about. So in this lesson, which was passing arguments by address, and in this lesson, we will discuss about that as well. The next topic that we will talk about is pointers, then memory, and at the last one is function templates. I hope we'll have enough time to cover function templates as well, but we'll see. So the exercises that we have were these three questions. The first question is, write a program in C++ to find the sum of the series. So it's a very simple program, and I'm not giving you the whole solution. I'm just giving you what this series looks like, and then you can implement it with a for. So the main question was related to the structure of these one, and how can you implement it with a loop function, with a loop. And here, so the structure is like this: 10 multiplied by 0 and plus 1, and again 10 multiplied by 1 plus 2. So as you can see, we have 0, 1, and then 12, and 1, 2, 1, 2, and then 1, 2, 3. And here also we have 1, 2, 3, and 4. So we can implement this program in one loop, and these values can be computed by our iterator. So if you know this thing, if you can interpret this list as this one, then you can implement it very easily. So the second question was, get a list of sorted numbers and a value. Check if the value is among the list. If so, returns its position. And we said to you that, well, how can we define an array of integers? And these are more similar to the C way of writing an array, but you can have it also in C++, but they are not really common. But since you are not familiar with standard template library yet, I ask you to just use arrays. So what's the answer for that? First, the most important thing here is that we know that the arrays are sorted. So we should go for a search method that is optimum for a sorted list. And the answer will be binary search. We should use the algorithm provided in a standard template library rather than implementing them by ourselves. But since, again, you are not familiar with a standard template library, this is the answer that you can have. You can implement binary search by yourself. But why we should use the standard template library rather than implementing them by ourselves? It's the answer is that a standard template library has been implemented by many developers and has been tested multiple times. So it's part of the library, part of the language, and it's stable and efficient. But if you try to implement it yourself, you cannot think that you cannot. You can write your program very stable and efficient, but when you have something that is stable and efficient, it's better to use that one instead of writing that yourself. Just give me 1 minute to check. I need to bring something here. Sorry, I need to see the time. So what is binary search? The binary search is, for example, this is our array, which is sorted, and I'm calling the binary search with this array, and the first elements of that is 0, and the last one is n minus 1, and the number that we are searching for is num. What does it do? It first finds the middle of the array, the middle of our list, and then check it with the num, the thing that we are searching for. And if it is equal, then it will return its position. If not, if it is bigger than, if the num is smaller than the middle item, then we know that it should be in the left part of the list. So then we use recursive function, we recursively call binary search here with the left part of the list and with the same item that we are searching for. But if, I think here is something wrong. It should be the other way around. So if it is smaller, then we will work with the left side, and if it is bigger, we will work with the right side of the list. So it will recursively call the functions, and it will find the location. It's more optimum, and it will give us the answer in a big O log n, instead of having, if you use, for example, linear search here, then the complexity would be big O n. So we want to have more efficient programs. So it's better to consider these techniques when you are implementing such a thing. We will study a standard template library probably in the next lesson or the lesson after that. So it would be much easier when you have a sorted list. You can first sort the list just by standard template library, or you can also find them with binary search. The third question was write a program which receives two variables of the same type and checks if they are equal or not. And I asked you to consider two different data types. Okay, let's see what are the examples. The first, what are the solutions? The first solution is to have two separate functions. So, but it's not really a good thing because they are the same. We know that they are doing the same functionality, but we should have two separate functions with two different names. The other answer is that we can use overloading. So we can have two functions with the same name, but with different parameter types. It is not the best solution because the functions bodies are totally similar, meaning that we are duplicating the code only because of different data types. You can look at the answer here. So I used function overloading to solve this exercise. It's so I have R equal and R equal. The name is the same, but the data types are different from each other. Even the number of the data types are equal, but the data types of the parameters are different from each other. But as you can see, the body is the same. So both are doing the same task. Function overloading is useful when the bodies are different from each other, resulting from different parameters, but the functions are doing the same functionality. So here the bodies are not different from each other. So the best answer is temporal functions, but it will be taught later. Probably today we will discuss about that. So this is the answer for the third question. And if I want to call this, I only calling both of them are similar to each other. And the only difference is that it can work now with either string values or integer values, and it will return the results that we need. So now I'm going to give you, okay, let's first ask you if you got that. Did you got the function overloading? Do you have any questions? No? Okay. Okay. Oh. So we have talked about passing arguments by value, by reference, and by concept. And now we are going to talk about by passing arguments by address. So the structure is like this, but since you're not familiar with pointer variables, we will first explain what pointers are, and then we will come back to this example to know how we can pass arguments by address. So pointers. A pointer is a variable that holds a memory address. A schematic representation of this variable is here. So look at this. This is just a variable, and its type is unsigned long integer. So it will reserve 4 different bytes of our memory, and this variable is pointing to this part, to the first byte of that. Inside these bytes, we will have some values. Each cell of our memory, each location of our memory has some address, as you can see here. So they have some address, they have some values. And a variable is pointing to the first item, and it will get 4 different bytes of our memory. Since it's just a variable and it's just defined, it's just regular variable, it's getting this info, these locations from our stack memory. Today we will discuss about different parts of the memory, but just remember that regular variables, when we do not have new or anything here, we are getting the memory from our stack memory. Okay, it was just a regular variable, not a pointer. But a pointer is a variable that holds a memory address. I mean this one, but how? First of all, we should know that I just said that every variable has an address, as you can see here. Okay, with this address of operator, with ampersand, we can get the address of our variable. We have here one variable, its value is 5. It's defined in our stack memory, and with ampersand ensures that I can get its address in the memory, and this is our value. A pointer can be defined like this. It's a pointer, and we are initializing it with 0. 0 is not a value in a location of memory. It's an address in the memory. But okay, 0 is not a real address. It's a null pointer. And age_p is now a pointer, and the address inside HP is 0. Initialization is necessary, I mean this one. Why? because if you don't do that, it would be a void pointer and it could be pointing to anything like this. So we don't know what is inside that pointer, and it can point to anything in our memory. But you know, operating systems, when they are running your program, they give you some addresses. You will ask the operating system to give you some addresses, but every program has its own memory space and it's different from other programs. So if you just try to access to a location of memory that the operating system didn't give it to you, then you will have, your program will crash because you have your access, you will have an access violation. So you should be really careful to access only the location of memory that you ask for. So it's better than it's really necessary if you are defining a pointer, initialize it with 0. Let's see this example. I'm here creating a variable in a stack memory with 5, as you saw in the previous slide. Here I'm printing its value, then its address here. Now I'm creating a pointer again in our stack memory. Okay, so it's the pointer itself is created in our stack memory, and the value inside the pointer is 0, which is an address. But if I print short p, it will show me this address. If I print the address of short var here, I can see, okay, sorry. If I set the address of short var here to this pointer, now this pointer has a value, and that value is an address. And it means that this pointer now is referring to this variable, to this location of memory. But it doesn't have the data inside that. It is only referring to the same location of memory. And if I print short var p, which is a pointer, now I will see this address. I mean the address of this variable. But we said that short var p is a variable in our stack memory, is a pointer variable in our stack memory. So it means that it itself has an address. So I can get the address of short var p by ampersand again, and the address is this one. So you should understand what are they doing. We have some variables. They are defined in our stack memory. Either they are regular variables or pointers. Variables, regular variables, have some values, and their value is just a value like integer value, string value, and so on. But pointer variables are, again, some variables in a stack memory, but their value are some address in memory. And they itself have some address because they are some variables. Another way of defining a pointer is that, okay, we said that we have auto, which is a useful technique. Instead of writing the type of your variable, you will ask the compiler to detect the type based on our initialization. So we are saying here the address of this variable, I want to save the address of this variable in a location of memory in the stack memory. So it will create a pointer of type integer like this one here for us. So, but we said that the pointer includes some addresses in the memory, but how can we see the value from that address of memory using a pointer. So this is indirection operator. It will help us access the memory, the value at the address held by a pointer. Okay, see that this example. Here I'm creating an integer variable, regular variable. Here I'm saying that I want to save the address of A in a variable, so it will be a pointer of type integer pointing to this location of memory, pointing to the address of A. Now I want to create an integer variable, not a pointer, with the value of the location of the memory that the pointer is referring to. So I will use the indirection operator to get that value. So here A would be 1398. Here AP would be the address of A, and here B will be 1398. And if I print that, okay, if I print that, you will see these values. Now I'm changing this location of the memory using the indirection operator. So first A will be 1398, and then the address of that in AP. B would be 1398. I'm changing that location of memory to 2019. If I change that location of memory, A and AP, since both are referring to that location of memory, will have the same value here. But B is just a regular variable that we have created using the value of that. So B is not a pointer. So B will have the same value as when it was defining. It has been defined. So this is the difference between pointers and regular variables. And let's see how can we pass arguments using pointers. We have here a function, and it has a pointer variable as its argument, as its parameter. And it's changing that location of memory, which one it is incrementing the value in that location of memory with 1. So here, if I create a variable like value, and if I pass that address of the value to this function, it will change value as well, because value and PTR are both referring to the same location of memory, and I can change it using indirection operator or using the value itself. So if I pass something by address, like by references, you can change it, and the function can change it. Something that is important, as you remember, we said that the parameters that are defined here are local to this scope, and after that, they will be deleted. So this is also the case with pointer variables. So after this one, we do not have access to this pointer anymore. So we said that we have, as we discussed, we have 4 different ways of passing arguments. The first one, passing by address, the thing that you have just seen, and by reference is just like defining a reference variable here and passing them by a variable. and by const reference. So in this case, you cannot change A, but there is no copy, and it's very good way to pass large data like classes, like all the data and structure that you have in standard template library, all the classes that you define for yourself, strings and so on. The last one is by value, that we only use it for fundamental data types like integer, and in this way a copy will happen and you cannot change the value in I mean, if you change the value inside A, the change will not be reflected to the arguments that you use, that you pass to this function. The change will also will only remain here in this function. Something that you need to know that I forgot to say, if you look at this, with this way, we are creating a pointer which is referring to this location of memory. If you remember, we have used also the ampersand for defining reference variable, but the difference was like this: ampersand was here, and we haven't had anything here. So we were saying that this variable is referenced if we put ampersand here and initialize that with just one variable, not ampersand. So don't confuse them with each other. Question? Oh, sorry. Did you get what pointers are? Okay, if you have any question, you can ask. So let's go to memory. So we have different memory segments for every program. So if you run a program, if the memory of your program would be similar to this one. First, we have this code segment, the initialized data. We are starting from the low address. The uninitialized data, the heap memory, and the call stack. And command line arguments and environment variable would be here. These are the things that the user is passing to your program. We have talked a lot about the stack memory. I mean, I was referring to this memory multiple times till here, and whatever you had till here was in our stack memory, not in our heap memory. But today I'm giving you, I'm trying to explain what heap and stack memory are. So the code, we are not going to talk about these three different things, and they are not much important for when you are writing a program. But the heap memory and call stack are very important. Let's first talk about this one and then come to this. The call stack. This stack is cleaned automatically when a function returns, or when we are going out from a scope. The amount of stack memory for a program is generally quite small. Usually it's 1 megabyte on Windows and 8 megabytes on Linux. What does it mean? So it means that you can have such an array, but you cannot have such an array. It will lead to a stack overflow. Or if you have many nested function calls, then you will have also stack memory, because you cannot, because every function call, by every function call, you are defining some variables in its in the stack memory. As a function has some arguments, has some parameters, and has some local variables. All of them are defined in a stack memory, and if you call it multiple times those variables will be created, because all of them are local to that function. So the reasons for a stack overflow, or when you have too many variables on the stack, or making too many nested functions. So it means that your program cannot be dependent only on the call stack and only on the stack memory. We need to use some other places to have more space. The other one is the heap memory. The memory you reserve remains available until you explicitly state you are done with it by freeing it or until the program ends, assuming your operating system cleans the memory up. So maybe it's not the case. So this is, again, the heap memory and call stacks are, I mean, the heap memory is not really similar to your hard disk drive. It's not a permanent storage. It's a memory that remains available until you release it or until your program ends. So how can we get memory from our heap memory? The way that we can do it is using new operator. And if I use new operator, it will get some memory from our heap memory. And now we have an address. How can we store that address? Okay, pointer variable, because pointer variables are including addresses of memory. So now instead of writing like ampersand, a name of a variable, we are using new int or new int5 or new any other data type. And by doing so, we are asking for a location of memory in which I can store an integer, and that address of memory will be stored in our pointer, and that pointer is a pointer referring to the address of memory whose value is of integer type. What does it mean? This means that I want 5 locations of memory in which I can store 5 different integer values. And the address of the first one is stored in this pointer. When you are finished with an area of memory, you must free it back to the system. So how can you free it back? Because we said that if you don't release it, it's not like the variables that you define in a stack that if you go out of the scope, they will be lost, they will be deleted. You should release it yourself. Otherwise, you will have memory leak or other problems. So to delete memory location, release it. To release that one, we write like this. We write delete PTR1. We are saying that delete this address of memory. And we are setting that to null PTR or 0. Null PTR is more common this entry. 0 is more C-like style. What does this mean? Because we said that if we don't set it to null PTR, PTR still is referring to the same to that location of memory. And if we access that location of memory, we will have a problem because we are accessing a location of memory that is no longer for us. So it's important to set it to null PTR. If we access a location of memory, a null PTR location, we will have again a problem. But at least if we delete a null PTR, we will not have any problem. But how can we solve this one? If we want to access to something, we should check if it is null PTR or not. If it is null PTR, it means that we cannot access that. And how can we show that an address of memory, if we have access to an address of memory, only if after its deletion we set it to null PTR. So, but usually if you are not familiar with classes, but usually allocating items from the heap memory is done in the constructor of our functions, our classes, and deallocating them is done in the destructor of our classes. We will see them later. So this one is a void pointer because it can point to anything, and we don't like it. We should initialize it by null PTR. Dangling pointer is a pointer that is pointing to the allocated memory, the thing that I just explained for you. Calling delete on a dangling pointer again crashes your program. So look at this example. I'm getting a location of memory of type int. I'm changing its value to 7. I'm deleting that. Now I'm having access to that. So it's an undefined behavior. Sometimes that location of memory is yours, but it's defined for some other variables, and you are just modifying that. Sometimes it might be for other programs, and then your program will crash. And here, even deleting that one, it will lead to undefined behavior. So when you delete your pointer, you should set it to 0 or null pointer. Calling delete on a null pointer is guaranteed to be safe. Using a null pointer is illegal and it will crash. Avoid having multiple pointers. Okay, you should not have multiple pointers to point at the same location of my. I should say that this is the case. These problems that you can see here are with the problems that we can have with a standard pointer. In your program, at least for the first part of your program, I mean for your first part of your project, you don't need to use a standard pointer. I will teach you what are smart pointers, and you won't have such a problem. But in the second part, then since you will start to work with Qt library, then you may need to use the standard pointers there, and then you should pay attention to these things. Or when you are working with some libraries that they are working with a standard pointer, so you should try not. I mean, nowadays you should try not to use standard pointers and try to use smart pointer as much as you can. I mean, whenever you need them, whenever you need a pointer, you should go for smart pointers rather than standard pointers. So with the standard pointers, it's better to avoid having multiple pointers pointing at the same piece of the dynamic memory, or set all the pointers to 0 after deallocating the memory. So for example, if I here define another pointer with the same, I can define multiple pointers pointing to the same location of memory. And if I delete one of them, it means that that location of memory is gone. And then I have to set all of those pointers referring to that location of memory to 0. Deleting is done once, but setting them to null PTR should be done for all of them. Because with delete, we are deleting that location of memory. But with setting to the 0, we are setting those pointer variables to the 0 address. Another problem that we can have with pointers is operator new can fail. So if I create, if I'm getting a location of memory from our heap memory, I can put std not row, then it will not throw an exception. But it doesn't mean that we will not have any problem. We have two ways to solve this problem. One way is the way that is written here. We can write CD note row here, and here, if we are going to access value first, we check it if it is a null pointer or not. If it is null pointer, then we are saying that we have a problem. We do not have a we haven't get that location of any location of memory. The other way is that, okay, we don't write this here, but we put this statement inside the try catch. Then if it throws an exception, I will catch it. But the try catch way is sometimes an ugly way of handling the errors, even if it has been used in many libraries, but this is not the best option. It's a middle way solution for that. Okay, what is memory leak? You usually hear this term in many different languages. And when you are working with a program, you see that after some time, your program will be very slow. You cannot work with your program well, and you don't know what's happening. Usually people said, okay, we guess that there is a memory leak. And if you go to the, for example, on Windows, if you go to your task manager and check the memory of that program, you will see that the memory is growing, growing as long as you are working with the program. This is named memory leak. Why it happens, how it happens. We have here a function which is creating a local scope. We are getting some location of memory from our heap, and we know that if we don't delete it, it will stay for us, and it will not be deleted anymore. And we know that here we are creating a pointer variable which is defined in our stack memory. So the value, this is a location in our heap memory, but this pointer is a variable in a stack memory. So after this scope, this variable, this pointer is released, but this location of memory that we got from the heap memory hasn't been released. So the more you call this function, the more memory you will get from the heap memory, and you are creating a memory leak here. So officially talking, memory leaks happens when your program loses the address of some bit of dynamically allocated memory before giving it back to the operating system. When this happens, your program cannot delete the dynamically allocated memory because it no longer knows where it is. The operating system also cannot use this memory because it is considered to be still in use by your program. So this address seems to be your address at the address of your program, but in your program, you don't have access to that anymore after this scope because you do not have this pointer anymore. So you should be careful if you are allocating a memory, getting a memory in a scope. When you are out of this, when you are about to be out of the scope, you should erase it. I mean, this is the last moment that you can erase it. You can erase it sooner, but the last time that you should check if all of your memories has been released is when you are going out of the scope. This is similar to the destructors in our classes. So usually you get memory in the constructors, And the destructor of your class, you should check, okay, I had these pointers first, and I should check if the pointers are referring to the heap memory or not. If they are referring to the heap memory, did I delete them? Did I release them? If not, I should delete them in the destructor. Or if it is inside a function, like this one, I should delete it here. We can use const keyboard with we can use const keyboard with also different with pointers. So we have here two different pointers. We have two different pointers here. Const int star x. It means that x is a pointer to a constant integer. So the value inside x is a constant integer. With this one, int star const y, we are saying it's a constant pointer to an integer. So with this one, the value couldn't be changed, but the address of x could be changed. With this one, we are saying that the address, the pointer is constant. So it means that the integer value can be changed, but the address cannot be changed. With this one, for both of them, we have const int star and const z. It means that both of them, the value and the address, the value inside this address of memory cannot be changed. And also the address inside this pointer cannot be changed. So this is the different way that you can use const when you are defining a pointer, and based on their location, they have different meanings. Okay, tell me what is wrong here. Okay, this is not. Okay, tell me what is wrong here. No guess?
I think if there's an error, it's on the line integer pointer p var equals. I don't know what the end sign is doing there. Is it some form of indirect addressing and then some variable?
Here or here? I cannot hear you. You're muted.
The line above, so integer pointer var equals that line. Yeah, I think it's over there, but I don't know.
Okay, okay, let me explain it again. With this one, we are getting an address of our variable in our stack memory. So some variable it's just a regular variable. It has been defined in the in a stack memory. And with this one, we are creating a pointer referring to the same location. So we are not working with heap memory anymore. It's just stack memory. But here we can guess if the programmer wanted to change some variable using this pointer. But we said that to change that, it should use indirection operator, not like this. By doing this, it's changing the address of p-var. And by doing this, it's not anymore referring to some variable. It's referring to another location of memory, whose address is 9. But it's not again safe to do this thing because we don't know if the address location 9 is for our program or not. So it's an undefined behavior for us because here now it's referring, with this one we will not see any error because it's just we are not using that address. But with this one we have an undefined behavior. If 9 is an address for our program, we got it before this thing, then it will show the address of that location of memory, not this variable. But if it is not, then probably it will crash. So to fix this one, based on the program that I can see here, I will just write an indirection operator and one asterisk here. Did you get it?
I still don't get what the end sign is doing in front of some variable.
Here, and is just an operator that will give the address of that variable. So with this one, as you saw, let me show you the example. Yeah. This is one variable, as you can see, just a regular variable. And here I'm printing that variable, 5, okay? But here I'm using AND short var, and it is giving me the address of this variable, okay? This is the address of this short var. It's a location in our stack memory, okay? But how can we store it? I cannot store it, for example, in an integer variable. I should store it in a pointer variable. And how can I do that? Like this. I define just a pointer, and I'm setting that address of variable to a pointer. I could write this one also here, like the example that you just saw. Or like this. So now, if I print short var p, like here, I will see the same address that we have printed here for short var. So short var p and ampersand short var both have the same values. Okay. So this is, for this one, we are only working with stack memory. Did you got it?
Yeah, I just thought it automatically went to the address, but thank you.
Okay. Okay, how about this one? What is wrong here?
The pointer is deleted, but then the location the pointer is pointing towards is used a little lower. So p_int is deleted, and then below that, the location where p_int is pointing to is referenced, which is illegal.
Mm-hmm. Yeah, true. So you should now compare to the previous example. Here I'm using new. It means that now I'm working with heap memory and also stack memory. Now I have both of the memories. In the previous example here, I only work with stack memory, okay? But here, the moment that I'm using new, it means that my program is using both of the memories. So, but what is happening, but if I getting information from our heap memory, then I have to delete it because otherwise it will remain, it will create leaf memory and so on. I'm here with indirection operator changing that location of memory, the value of that, and I'm deleting that. First of all, I should set pint to null PTR here to let the rest of my program know that I don't have any address for this pointer, okay? And whenever I want to use this pointer, first I should check if it is deleted or not. Okay, in a simple function like this, you don't need to check it again. But in different, it can be in a bigger scope, okay? There you have to check, and you are using a pointer to see if it is pointing to a legal address, if it is pointing to something or not. Here, I'm using a pointer that is no longer for us. I'm trying to change that. So by doing so, we will have, our program will crash because we have a access violation. So the good practice is that first we write here pint equals null PTR, and here if you are going to use it again, first of all, we should not write this, but imagine, okay, we wanted to do that. We write if pint, then do this one. So it means that it has an address. Okay, okay, what is wrong here with this example?
It's an infinite loop. So it's a recursive function that calls itself, but it has no condition of stopping the recursive loop. So it just goes on and on.
Yeah, but do you know what is the error that you will get?
I think it will be Stack Overflow, because each time there will be push something onto the stack until it runs out.
Yeah, true. As your friend said, it will cause a Stack Overflow, as we also explained before, because with every function every function has its own local scope from stack, and by calling them recursively multiple times, many times, for example, here is just infinite recursively calling this function, you are getting the whole memory from a stack, and so you will have a Stack Overflow. So this is another problem with a stack. Let's talk about function templates. I try to teach faster, and now I was worried that we will not have enough time for function templates, and because of that I taught faster than usual, but apparently we have enough time. But it's good now I can slow down, and this part is more important because for pointers, you have smart pointers, and it's less, nowadays it's less common to use the standard pointers, but function templates are very useful and very good technique of programming in many different languages. Let's see what they are. Before that, if you have any question about pointers, you can ask. No? No one? Okay. So, function templates. Suppose you have defined a function to calculate the maximum of two integer values, int max, int x, and int y. So if I want to have such a function to get the maximum of two integer variable, I can just write it like this. It has two integer variable, integer parameter, and I'm using conditional operator to get the maximum between these two variables. But later you realize your function needs to work with doubles. What is the solution here? As you had in your first exercise, you have different solutions for this one. First, replacing int with double. So if I write double here, I can call it with either with integer value or with doubles or any other numerical values. But it's not really good. It will give you some warning, and we know that warnings are a sign for potential bugs, and we should fix them. We should not do such a thing. We should not pass an integer to double, double to integer, because then we will have some problem. We may have underflows. We may have overflows for our different variables. So the other solution is that we can overload max with the same function, the same name, but with the same number of input, the same number of parameters, but different data types. This is similar to the example, to the exercise that we had in the beginning of the lesson. We solve it with overloading function. We were checking if they are equal or not. Here, the example is saying that it's how can we get the maximum of 2 integer values, the maximum of 2 doubles. There, our example was to see if 2 integers are equal or 2 strings are equal. But even that time, we said that is not efficient. Why? Because the body of them were exactly the same. So it's inefficient. Note that the code for the implementation of double version of maximum is exactly the same as for the int version of max. So overloading, as we said before, is useful when we have one task that is going to be done for different data types, and it should be done in different ways. The way that we do that task is different for different data types. So, but they are doing the same functionality. Then we use overloading. But this is not the case. We know that we can have the same body for doubles. So the best answer is to use templates. The general programming guideline is that in every languages, duplicate code should be minimized as much as possible. So if we write just this one for doubles again here, then it means that we are duplicating this body of the function again in other places. And if you want to change this function, you have to change it in other places. This is very against what the guidance says. We should not duplicate, because then it's very difficult to follow to track the changes. This is the reason that we are using given functions. We are trying to put a piece of a functionality, a piece of code in one function and use it in different places. And if we want to change that functionality, then we can change it in that function, and it will be propagated to wherever it is called. So function templates are the function that serve as a pattern for creating other similar functions. Look at this one. We have int +1 int, and it's the input value of that is a, and we can plus it by 1, and we can increment it by 1 and return it. But how about if I want to use it for other data types? I can just convert this one to be a pattern for other similar functions. How? There's a keyboard name template. Then we have this one, type name, a name, which is our placeholder. And I'm saying that I want to have a function which has a placeholder named t. This placeholder is a data type, but we don't know what it is until we call this template. I can use this placeholder inside this function in every location that I want, either in function parameters or in the return value or in the local, for the local variables that we define in this function. Okay, so what will happen by call a template function? The compiler replaces the placeholder types with the actual variable types from the parameters in your function call. So if I call it, for example, with int, then t would be int for every location that you will see t in this function. Or if I call it with double, then it will be double for every location or a string or any other data type. So here is another example. I'm writing a function that is doing the division between input value and 2. And it will give me the result. I'm saying that the input is of type T and the return value is also of type T. How can we call this template? I can call it like this: div2 int. I'm saying that replace T with int, and the argument here 3 is for this one. And since I'm saying int here, it will replace this one with int, this one with int, and this one also with int. So with this one, since all of them are ints, the division would be an integer division, and the answer would be 1. But for this one, I'm saying that the division, this function should be created for myself, for me, with double. So all of them will be replaced with double, and I call it with 3. Then since imp and imp is double, the division here will be a double. Yes, it will be a double division, and it will give me 1.5. So as you can see, the body is the same. The data types are different from each other, and the result is different from each other based on the data type. This is exactly what we expect from this template function, that we need to have different results if it is int or if it is a double. If I just write this function with just double, then if I even send 3 to that, since it is double, it will do it like a double division. So this is the way that you can write a function performing one task for different data types. These two are two other different ways that you can call a template. So you don't have to write this thing here. It can realize that from the type of the data. So here it's and there's like auto that that can detect the type of the data based on the values that you are passing to that variable. Here also it's the case. Based on the type of this value that we are passing to this input data, we know that how can the T should be replaced with the data type int. So, but both are. It's more recommended to use this one, because when you are reading your code, then you can realize that how it is working. So in this case, for templates, unless for auto, that I was suggesting it's better to use auto. Here I suggest you to use int and double, because it can be more complicated than this. These are just fundamental data types, but templates can work with any different, any classes, any data types. Where do you need to use these function templates? In your first project, okay, I think we have, okay. In your first project, you remember you have some comments, and every comment, I mean, the select comment has some conditions, and inside that condition, you have, for example, age, braces, and int. There you are doing the same task, you are doing the same functionality for different data types. So there you can use function templates. You don't need to write this, for example, equals, greater, lessons are the same for different data types. Either they are int or double or strings. They are not strings, but for different fundamental data, numerical data types, they are doing the same. But the user wants to do this based on what they ask. So for example, the user asks you to do this comparison considering the fact that these values are integer, or these values are double, or these values are a string. Then you have to use template function. For strings, you need to use template specialization. As you may notice, during the course, I'm giving you the answer for every location of your project. So I haven't write them in the project definition. I said to you that you should use these concepts in your program, but I haven't said where you can use them directly. But during the course, I'm giving you these hints so you know where you can use these concepts. So consider these things and then implement your program. Another example that we have here is till here we saw that we have a function template that can work. That can have one placeholder, but it can be more than this. It's not like that we have to only have one placeholder. For example, here I have two different placeholder, and I'm defining that like this with type name X and type name Y. I can again use these X and Y in different locations in my template function. With this one, I'm I'm saying that it should be in the previous example here, it was passing by value. You are familiar by passing by values, but here I'm passing them it's called by references, const references. So it doesn't mean that, okay, if you have a template, it's not, called by value is not the only way that you can do that. You can pass the arguments in different ways. You can pass by parameters, whatever you had for regular functions, you can have also for templates with their placeholder. So const X and the ampersand, which is saying that I have a data type with this placeholder and it's const by reference. Also, the second parameter is of Y and the third parameter is of type Y. And the function is saying that if value is greater than 0, then return the concatenation or the sum of these two different values, depending on how you will call this template function, and then return this one. When I was creating this template, it was in my mind that these two should be a string and this one should be a value. But as you know, we can call this template also for double. For example, here it can be, this one can be integer, this one can be double. And then if it is double, the plus would be the plus that we have for double operands. And if it is a string, the plus would be the concatenation operator. The example I gave here to you is just a string, but I could put here, for example, int or double and pass to double values and then get different results. So the body is the same. What they are doing, the action based on different data types is different from each other. But I can use that template for any different data type, and I don't need to rewrite that code multiple times. I don't need to rewrite it in overloading. So here E is 1, it's greater than 0, and it's of type int, and I'm calling I'm defining to a string data type here, and I'm with this one I'm concatenate. I'm calling this concatenate message here first with int. It will go here, return the concatenation between message and name. With double, I can create this one with double and pass integer to that, and also double with pass 2, and so it means that I'm saying that the first placeholder should be int here and should be double here, and for this one it should be string. So it will replace this one with a string. So you can have such a thing and implement them. And in the next lesson, we will discuss about template specialization. It's like having overloading next to your template function. You have an overloading of your template function, but it's not exactly like overloading. It's not overloading, but it's similar to that one. So the exercise that you have for for the next lesson is that you should write a program which receives two variables of the same type and checks if they are equal or not. Consider the following data types. So the first thing that you don't, yes. The exercise that you have, you have done this exercise. I gave you the solution to this exercise in the beginning of this lesson. But the solution that I gave to you was overloading, but this time you should do it with templates. And in the next lesson, I will give you the answer to this program, to this exercise. The next exercise is to write a program which receives two variables of the same type and checks the following conditions. For int, it will check if it is bigger, smaller, and equals. For a string, it will only do the comparison. This is where you need to use template specialization, because the body of a string is kind of different from the body of integer. So this is the whole lesson that I was planning to give you in this lesson. Now you can do some exercises or ask some questions. Otherwise, we can stop the lesson, because I think these are enough for this lesson, and I have also a meeting at 10 again. But I'm here, don't worry, I'm here, and if you have any question, you can ask. If you want to do some exercises, I'm here till 10, I have time. No question. What is your suggestion? You want to stop the lesson now, or you want to do some exercises? You can do these two exercises now, for example, especially the first one.
I think I'll do these exercises better as homework.
Okay. Okay. I think this is also the case with the other people. I hope they are not asleep. Okay. No one has any questions. I mean, we are getting to more difficult topics. So if you have any questions, you should ask. You should study that. And the more, I mean, in the next lesson, we will talk about standard tempo. I can show you. Let me see. Let me see here. Okay. So the next topic that we are going to discuss so we have discussed about till here function templates, and then we are going to first I will give you the answers for the exercises, then template specialization, then a standard template library. Probably I will also add here I only gave you some containers, but probably I will also talk about algorithms and some ways that you can work with paths and also with strings. Usually I gave those lessons in the last lesson of the course because in the last year, I mean, in the last year and also the year before that, we got the project after 1 month that the lesson was over. But the problem was that usually students were very busy with other exams and other projects. So we decided to get it to have it sooner. And because of that, I have to move some topics from the last lesson to here because you need them to use it in your projects. You need to know how to work with strings with different paths. But in the last year, it was not like that. People haven't implemented their project till the end of the course. But I think you are planning to implement it as soon as possible. Okay, if you do not have any questions, we can stop the lesson. Okay, have a nice day, everybody, and see you next week.
See you next week.
See you next week. Bye-bye.
Bye.
Bye.
See you next week.